Okay, and welcome to your tutorial on finding the gradient of a line. Today we're going to look at what a gradient actually means and how we can find them drawing these graphs or these linear relationships we have been looking at for the last few lessons. So the gradient of a line, you need to write this down, is the measure of its slope. How steep is a line? You'll notice when you've been drawing some of these, some lines have been steeper than the other. Today we're going to work out how we actually express that steepness as in mathematical terms, It's a number, like I just said, which describes the steepness of a line, and it's calculated by how far a line rises, so how far it goes up, how far it rises, or falls between two different points on a given horizontal axis. The horizontal distance between the 2 points is called the run. The vertical distance between the 2 points is called the rise. Rise over run. And that's how we actually express the formula for finding a gradient. A gradient can be found using the following formula. Gradient, or we represent the gradient with this letter called m. Gradient equals rise over run. So, like I've said, the vertical is my rise and the horizontal is my run. So from this point here, I go out 1, 2, so my run is 2. From this point here, I go from 2 all the way up to 6, so my run is 4. So my rise is 4. My run is 2, goes across from 0 to 2. My rise here is from 2 to 6, so my rise is 4. And I represent that gradient as my rise over my run. So 4 over 2, and then 4 divided by 2, m equals 4 over 2, because that's my gradient. M equals 2. 4 divided by 2 is 2. And that's how I represent a gradient, guys. It's not too tricky. Okay, the gradient can either be positive, negative, 0, undefined. We're only at the moment going to have a look at positive and negative gradients. So if my line is heading this way, so it's heading up towards the right, okay, it's sloping that way, it is a positive. So this one here is a positive gradient. If my line is sloping this way or sloping towards the left, it is a negative gradient, okay? Positive towards the right, negative, it's sloping towards the left. Okay, so now I'm asked to find the gradient for each of the following graphs. I've just showed you this example before and we're going to do it again. Okay, so the first thing I do is I need to find where the line hits the y-axis. And it hits the y-axis here at 2. So that's my starting point. Now I can go as far as I want. It doesn't matter how far along I go on the y-axis. I can go out as far as I want. I could go out from, here, and I could keep on going, and then I could go all the way up. It doesn't matter how far I go along, okay, because the gradient, the rise and the run are always going to be the same because it's a straight line. However, I'm just going to make my life a little bit easier, and I'm only going to go out to this point here. I'm going to go out to the 2 because I can see that's marked on my axis. And that's my run. So now I need to know what my rise is. Then I grab my line from whatever point I got to. I go straight up until I hit the line. Okay, so now that will get my run as from 0 to 2, so that's a run of 2, a rise from 2 to 6, because that's where it hits, and a rise of 4. So my formula says my gradient equals my rise over run. My gradient is 4 on 2, or 2. Very straightforward. Okay, let's have a look at another different example. Okay, this time because my lines are negative, I again have to find where it hits the y-axis, okay? I find where it hits the y-axis, okay, and that point is at positive 3, okay? And again, I go out. I go out as far as I want, but look, to be honest, I'm going to go out to this point here, okay? I go out there, and then I hit down, and that will give me my rise. Now, as you can tell, my rise this time is going down, okay? So this is why this is a negative, this will have a negative gradient because my rise is actually going down on my graph. So my gradient equals my rise over my run, okay? Now my run this time is from 0 to 2, so my run is 2, and my rise goes from 3 to 0. My rise goes from 3 and it goes all the way down to 0, so it's actually a rise of negative 3. Okay, because it is going the opposite direction, so it's going to be a negative. So m equals my rise, negative 3 divided by 2. Okay, and I can just simplify that to negative 3 on 2, or negative 1.5. Either way I want to represent it, it doesn't really matter. I would pretty much prefer if you left it in this form, okay, because that's saying my rise over my run. Okay, another way that we can represent gradients is from two particular points. So it can ask you, find the gradient of 4 from 4, the first coordinate is x4, y2 to x8, y10. Now, that's going to be really bloody hard if you don't draw a graph. So we have a particular formula. This is my first x coordinate and my first y coordinate. So I represent those as x1 and y1. They're my first ones, that's all I'm saying, okay? These are my second x and y coordinates, so I represent that as x2 and that as y2. In order to find out the gradient of them, I simply take y1 minus y2 and x2 minus x1. So y2 minus y1, x2 minus x1. What that's saying, guys, is it's saying, okay, y2 is the point at which my rise ends. That's the high point. That's the end point of my rise. Now, it starts at 2. If it starts at 2 and goes all the way to 10, how far is that rising? If it starts at 2 and goes to 10, how far is that rising? Well, it's rising 8. Then, if it starts 4 and ends at 8, what's that in between? Okay, so x2 and y2 represent the end points. x1 and y1 represent the start point. So if it starts at 4 and ends at 8, that's a difference of 4. So my gradient can be represented as y2 minus y1, x2 minus x1. It's pretty straightforward, guys. It's not too hard. All you have to do, this formula looks really, really complicated. If you understand what that's actually saying, that will help you far, far more, okay? So it's this idea that if I'm asked from 2 points, I can use this formula without having to draw a graph. So let's have a look. Okay, it says find the gradient of a line joining at the given points. So joining at these points. Now, I said originally that my formula was my gradient equals my second y and my first y over my second x coordinate versus my 4. So where it ends up, subtract where it started from. Where it ends up, subtract where it started from. That's all that's saying. Okay, so y, and a good practice when I get a question like this is I like to actually draw it in. So this is x1, y1, x2, y2. I just quickly plop them in. So I know that I can just quickly put them into my formula. So my gradient equals y2 is 6. Subtract y1, which is 4. x2, which is 5. Subtract x1, which is 3. So 6 subtract 4 is 2. 5 subtract 3 is 2. So 2 divided by 2, I have a gradient of 1. That's it, guys. Simply substituting into formula. Now, the thing that'll freak you out is that formula. It does look a little bit tricky as long as you understand what it is that you are doing, okay? As long as you understand. What that formula is saying is, where did I start? x2, y2. Where did I end up? y1, x1. And that's it, guys. That's finding the gradient of a line.